For decades, we've measured AI's progress by its speed. Faster responses, quicker computations, and split-second decisions. Tech companies race to build systems that could answer our questions before we finish typing them. We never stop to ask, what if being faster wasn't the answer? At last week's Mumbai AI Summit, Nvidia CEO Jensen Huang challenged everything we thought we knew about artificial intelligence. His company, which built its empire on making AI faster, had discovered something unexpected. The next leap in AI isn't about speed at all. It's about teaching machines to slow down and think. When you ask today's AI a question, you get an answer in milliseconds. That's how we designed it. That's what we celebrated. But Nvidia's new approach turns this idea on its head. They've created AI that actually takes time to process complex problems, just like we do. It's the difference between asking someone their favorite color and asking them to explain why they chose their career path. One needs a quick response. The other deserves some thought. This new AI works in two distinct ways. The first is what we're used to, rapid-fire responses for simple tasks. Need to know tomorrow's weather? Convert euros to dollars? Find the closest coffee shop? That happens instantly. But then there's the second way, a deeper level of processing that kicks in for complex problems. When you're planning a month-long trip across multiple countries, juggling flight times, budgets, and local transportation, you don't want an instant answer. You want something that considers all the angles, weighs different options, and finds the best solution, not just the fastest one. Nvidia's testing these systems in real-world scenarios right now. Take their work with a major shipping company. The old AI would instantly plot delivery routes based on distance. Quick, simple, done. But Nvidia's new system considers weather patterns, traffic history, construction schedules, and even local events that might cause delays. It spends time analyzing these factors, sometimes taking several minutes to map out a route. The result? Delivery times improved by 31% because the AI took time to think through all the variables a human dispatcher would consider. The real breakthrough isn't just about making AI think longer, it's about teaching it when to think longer. In testing, Nvidia found their AI naturally adapted its response time based on the task. Simple math, lightning fast. Complex financial forecasting, it took its time. This flexibility showed up in surprising ways during their trials. When the AI helped doctors analyze patient data, it responded instantly to basic vital sign checks, but spent up to 40 seconds processing complex symptom patterns. Doctors actually preferred this slower, more thorough approach because it matched their own decision-making process. But Nvidia didn't stop there. They're now building what they call autonomous agents. AI systems that can actually run themselves. Not the basic chatbots we're used to, but AI that can handle entire workflows without constant human input. During a 3-month test at a manufacturing plant, these agents managed quality control operations. They didn't just spot defects, they learned from each inspection, adjusted their criteria, and even started predicting where problems might occur before they happened. These agents run on 2 massive systems Nvidia built, AI Enterprise and Omniverse. Enterprise is where the agents learn their jobs, processing millions of examples until they understand their tasks inside and out. Omniverse is their practice ground, a virtual world where they can test what they've learned without real-world consequences. Think of it like a flight simulator for AI. Before an agent takes control of actual factory equipment or starts managing real customer service interactions, it proves itself in this virtual space. To keep these AI agents in check, Nvidia created a management system called Nemo. It's basically a digital supervisor that makes sure each AI stays focused on its job. During testing, they put Nemo through increasingly complex scenarios. They had one AI agent handling customer service suddenly start trying to access shipping logistics. Nemo caught it and redirected it back to its assigned tasks. Another agent began making decisions too quickly, falling back into old patterns of instant responses. Nemo detected the shift and adjusted the agent's processing parameters, forcing it to slow down and think through its choices. The impact of these changes showed up in unexpected places. Take a car manufacturing plant in Germany that tested Nvidia's system. The old AI would spot a problem on the assembly line and immediately shut everything down. Safe, but expensive. The new AI takes a different approach. When it detected a minor misalignment in door panels, it spent 15 seconds analyzing production flow, inventory levels, and maintenance schedules. Instead of a full shutdown, it adjusted the line speed and rerouted components, saving the plant millions in stopped production time. The factory workers started calling it the thoughtful overseer, high praise from people who typically view AI with skepticism. But the real game changer is what Nvidia calls physical AI, machines that can actually interact with our world using this new way of thinking. They're not just talking about better factory robots. During testing, they put an AI-powered robotic arm in a warehouse. Traditional robots would freeze if they encountered something unexpected, like a box in the wrong position. This one paused, analyzed the situation from multiple angles, and figured out new ways to grip and move objects. When it encountered a completely new type of package, it spent 27 seconds studying it before deciding how to handle it safely. The system making this possible is built in 3 layers. The DGX computer handles the heavy thinking. It's like the brain that processes all the complex decisions. During a demonstration, it managed to teach a robot how to handle delicate electronics in just 4 hours, a task that usually takes weeks of programming. The Omniverse layer creates perfect digital copies of real environments where these robots can practice. They made thousands of mistakes in this virtual world, learning from each one before touching actual products. The final piece, Jetson AGX, puts all this learning into action in physical machines. These advances are already changing how entire industries work. A major online retailer tested Nvidia's system in their returns department. The AI doesn't just sort returned items, it studies patterns in returns, analyzes customer feedback, and suggests changes to product descriptions to reduce future returns. In one case, it spent several minutes reviewing return data for a laptop and discovered that customers were returning it because the product photos made the screen look larger than it actually was. The AI recommended new photo angles and updated the description, cutting returns for that item by 42%. The shift is even more dramatic in healthcare. A hospital in Singapore implemented Nvidia's system in their diagnostic department. Instead of the usual instant analysis of medical images, the AI now takes a more measured approach. When examining complex scan results, it spends up to 3 minutes comparing current images with thousands of previous cases, factoring in patient history, recent research, and treatment outcomes. During the trial period, it caught subtle patterns in lung scans that even experienced radiologists had missed. The key wasn't better image recognition, it was taking time to consider context and connections that faster systems would have skipped over. This new approach to AI is reshaping how we handle data too. Traditional systems would crunch numbers and spit out forecasts based on pure statistics. Nvidia's AI adds layers of understanding that mirror human expertise. When a major retail chain used it for inventory planning, the system didn't just analyze sales numbers, it studied social media trends, weather forecasts, local events, and economic indicators. For the first time, the AI actually held back from ordering popular items, something that seemed counterintuitive until it explained its reasoning. It had noticed early signs of a fashion trend shifting and prevented the chain from being stuck with soon-to-be outdated stock. The technology is proving particularly valuable in crisis management. Emergency response teams in Florida tested it during hurricane season. Unlike previous systems that made evacuation recommendations based purely on storm paths, this AI considered dozens of factors. It analyzed population density, traffic patterns, hospital capacities, and even social vulnerability indexes. When Hurricane Laura approached, the AI spent 90 seconds processing scenarios before suggesting an evacuation plan that differed from standard protocols. The result, a 40% reduction in traffic congestion and more efficient use of emergency resources. That's really what Nvidia's breakthrough comes down to. Not just making AI smarter, but making it work in a way that feels natural. The future isn't about faster machines, it's about machines that know when to slow down and think. Thanks for watching.